Question number 16 on our test 2 review is also another example of a compound inequality, but this time instead of using the word and like it did back in problem 15, we're using the word or. So let's go look at our little piece of paper. Come on with me. And we will see, here we go. There we are. All right. Oh, we have our little friend the bee flying around. Okay, what we're going to do is we're going to do this problem again using helper graphs. But we're not ready. We need to look at the first part of this problem and get x by itself by adding 11. So x is less than 31. The word in the middle is or, which this time is basically going to tell us to union the helper graphs rather than intersect them. On this part of the problem, we're first going to subtract 2, which gives me that the opposite of x is less than a negative 17. But of course, we can't leave the negative 1 in front of the x. We have to either multiply or divide both sides by negative 1 of this inequality, which is going to make this say x is greater than 17. So here we go. We've got x is less than 31 or x is greater than 17. So what I'm going to do is I'm going to draw 3 helper graphs. X is less than 31, so I put my paren and I shade off toward negative infinity. X is greater than 17, so I put my paren, mark 17, and shade off to positive infinity. Now what we remember is that the word or, okay, the word or is a lot more accommodating. Or means to take the union of these two sets. And what that means in English is, in order to get down to my final answer graph, all right, all that has to happen to get down to my answer graph, all that has to happen is the number has to just appear in one of these sets, not in both like it did with and. Well, if you look at these two sets, if you take all of the numbers in this set, you take all of the numbers in this set, and you put them all into one large room, you're picking up the entire number line. Now, if it was an and, of course, you would just have the numbers between 17 and 31. But the or brought along everything from this direction, including everything from this direction, which was one big number line. Now remember, on a number line, this is the negative infinity direction, this is the positive infinity direction. So to write the set of all real numbers using interval notation, we're going to put paren, negative infinity, comma, positive infinity, paren. So graphically, this is our final answer. In interval notation, this is our final answer. If we want to write our final answer in set builder notation, one way you may commonly see it done is this. The set of all x's such that x belongs to the set of real numbers. Remember, this is a belongs to symbol from set theory. Another way you may see it written is the set of all x's such that, and then the negative infinity symbol is put, the positive infinity, x is sandwiched in the middle. And all of these are correct ways of writing the final answer to this problem, namely the set of all real numbers. Okay, goodbye, B.